The law of cosines.
Okay. First of all, what is it? In other words, what's the general format for the law of cosines?
B squared equals A squared plus C squared minus 2AC cosine capital B.
Good. What's another one?
A squared equals B squared plus C squared minus 2BC cosine A.
All right, you got the pattern clearly.
Yeah.
Okay, so let's do a problem. What kind of triangle are they giving you?
They're giving us the side lengths.
Okay.
So they gave us for side A is 9, B is 3, and C is 11.
Okay. We could draw a triangle, but we really don't need to. Which equation should we use?
The B squared?
Yeah, you pretty much have your choice. You could use any of the three because we're going to end up solving for the cosine of B. In other words, when we use that equation, we know B, A, C, A, C. The only thing missing is the cosine of B. So that lets you get that angle. Then you can go to town with the law of sines.
Okay.
That's the way the law of cosines always works. You only use it in two situations, one where you have all three sides, the other where you have side angle side. In other words, whenever you have either of those situations, you can't use the law of sines because you don't have an angle and its opposite side. So those are the ones where you have to start off with the law of cosines, but you always, as a second step, use the law of sines even here. So let's solve this. So I'm going to get you started. That's B squared.
That equals
A squared. C squared. I think I did that right.
looks right.
9 squared plus C squared equals 9. Okay. So now we get 9 equals 202 minus, let's see, what's 22 times 9? 20 times 9 would be 180 plus 18, so it should be 198. Cosine of B. Now you tell me what the rest of the things I should do.
So do you have to isolate cosine B?
Exactly.
Okay, so it's
In other words,
9.
the only variable at this point is that angle B.
Okay.
So before we can solve for angle B, we have to solve for cosine of B. And then once we get that, we can figure out what B is.
Okay. So it'd be 9 equals 4 cosine B. And then we divide by 4 on both sides.
Hold on. So we're going to take the 202 to the other side, where it becomes minus 193, correct?
Yeah.
And that's equal to minus 198 cosine of B. What's my next step?
Do you have to divide negative 198 by both sides?
Yes.
Okay.
Say it the other way, though. What you're doing is dividing both sides by negative 198. You're
Okay.
not really dividing 198 by both sides. It's the other way.
All right.
So that becomes that. Now I can just get rid of that. So now you have to look in your calculator to solve that. And
Okay.
how are you going to solve it in your calculator? What are you going to do?
Negative 193 divided by negative 198.
Well, in order to solve for b here, you have to take whenever you're solving for angles, know that you're going to have to use an inverse trig function.
Okay.
Okay? And one way I can write it is the following. I'm going to take the inverse trig cosine of the right side, and I'm going to take the inverse trig cosine of the left side. Well, the right side, when you take the inverse of the function, you just get the angle. And now tell me what the calculator gives you in degrees, I presume. You in degrees or radians?
I'm in degrees.
Okay. And do you know if that's what they want? Yeah, probably. When you're doing triangles, you usually leave it in degrees, not radians.
Yeah. I got 12.9.
Yeah, that makes sense. Given that cosine of 0 starts out at 1. Okay? And then, in other words, here's the curve of cosine. So the cosine of 0 is 1. So even though I can go up to 12 degrees, I'm still going to be a pretty high number, which that 193 over 198 is. That's like 0.96 or something. Okay, now, do they want you to solve the whole triangle, or are we done?
No, they just want that angle.
Okay. Now, if you get a situation where you get to this step, cosine of that angle, and this number is greater than 1, what does that mean? In other words, let's say we came up with the cosine of b equals 1.1. What would that mean? First of all, can cosine be 1.1?
No.
Okay, so that's impossible. You always have to have the sine and the cosine be between the numbers -1 and 1.
Okay.
Greater than or equal to them. They can be 1, or they can be -1, but they cannot be 1.1. And what that tells you is this is not a legitimate triangle. Now, since it wasn't greater than 1, that is a legitimate triangle. But had we gotten that, that is what it means. It means that there's no such triangle with those 3 dimensions on. And it's certainly possible to come up with triangles like that's not a triangle, 9, 3, 13. Can't have a triangle like that. One side always has to be less than the sum of the other 2 sides, and 13 is not less than 9 plus 3.
Okay.
So that's an impossible triangle, and if I were to use these numbers, 9, 3, and 13, I would have come up with cosine of b as a number greater than 1. And that would have notified me that that's an impossible triangle had I not noticed it in the first place.
Okay.
Okay?
So if it was 12, would it work, or is that no?
No, it has to be less than, not less than or equal. It has to be less than. In other words, 12 is not less than 9 plus 3.
Right.
And notice why that's the case. Okay? If I have a triangle like that, and one of my sides is 3, and the other side is 9, the only way that's possible is if that is the same line. The moment, in other words, the shortest distance between two points is a straight line. And this is not a straight line. It's a hooked line. So it cannot be that you would not be able to have 3 and 9 and have a triangle. All right. I'm going to try one where the other situation where they give you side angle side, they must have one like that.
Let's see. Yeah, so this one gives us angle B is 45 degrees, and then side A is 11, and side C is 22.
Yeah, notice that if I were to try to use the law of sines, I can't use it. I have no pair.
Right.
Okay, so I have to use the law of cosines. So which one am I going to use now?
The B squared.
Probably
The
have to
top.
use that one because this is the only thing they've given me. Well, not the only thing, but that's the key thing that they've given me is that angle.
Right.
Okay, and they didn't give me little b. So I've got b squared. This solves a little differently. The algebra unfolds a little differently. So do you have your calculator in front of you?
Yeah.
What's 22 squared?
484.
It's always minus cosine of 45 degrees. Go ahead and go ahead and give me a decimal on that.
Okay. 0.7.
Out a few more places.
0.7071.
All right. Okay. The reason I kind of hate to do that right here is because I'm also then going to take the square root of this number. So I'm going to accumulate round off error. I would
Right.
almost have preferred to put 1 over root 2 or, root 2 over 2 and worked it out that way and not rounded it off to the end. But it makes the math a little more difficult. So did you come up with that number yet?
No.
Let's go ahead and do that. Let's see, this is 605, this part.
Yes.
And I don't know what all of this is. What's all of that?
So I multiply the -2 times 11 times 22 times 0.7.
Yeah.
Okay. I got -342.24.
Okay, so now that becomes what? 262.76. Now take the square root of that. Square root of 262.76.
Okay. I got 16.2.
Yeah, now we're going to give it the ballpark test, mainly because it's really easy to make a mistake over here, especially when you're inputting it into the calculator. I mean, if you
Yeah.
try inputting it all at once, like b is equal to the square root of all of this, I would never trust myself to do it properly.
Right.
But that sounds like a reasonable answer. Now let's just see if it is. And again, do they want you to solve the triangle or? Probably do. They want you to solve the whole triangle, don't they?
Yeah.
Okay, so let's finish solving it. What's the next step? So far we've got one angle and its opposite side, and then we have two sides.
We need to find angle A and C.
Okay, using what?
We could use the bottom equation for the angle A.
using the law of sines. In other words, so far the only thing we've used is the law of cosines. But now to finish this triangle, you have to use the law of sines. You can't use the law of cosines anymore. And you have the ingredients for using the law of sines, which is you have an angle and you have its opposite side. That's always what you have to have. And I can do it either way. I can do it 16 over 2. I can do it like that. And I can say that has to equal what?
22.9.
No. Yeah, I'm sorry. I didn't mean for you to come up with a number. Using the law of sines, here's what the law of sines says.
Oh, and then there's, yeah.
Which, whenever you have a triangle where you know an angle and an opposite side, you can use this to figure out the rest of the triangle. Okay, so this represents b over the sine of b. We just figured out b. Okay, so let's solve for a next. So equate it to that.
So it'd be 11 over sine a.
And notice there's only one variable, sine a. So let's solve this. What do I have to do to solve this?
You have to distribute or get rid of the 11.
Cross multiply. Whenever you have one fraction equals another fraction, almost always the correct thing to do is to cross multiply. Get rid of both denominators in one step. Okay, now since I'm trying to solve for that, I'm going to divide both sides by 16.2. This gets rid of it right there. Okay, now that's just a number. What is it? Let's first find out what that number is. And that'll be what the sine of a is equal to.
I got 0.48.
That's good. We're between 1 and minus 1. Now tell me what angle A is. It's the inverse sine of 0.48.
Okay.
Always remember that you take trig functions of angles to get numbers. And you take inverse trig functions of numbers to get angles. So when you're solving for an angle, you almost certainly are going to have to use the inverse trig function.
Okay. I got 28.7
degrees. Okay. Now, we have 5 pieces of that triangle. How do we get the 6th piece?
Could we do it by adding 45 plus 28.7?
Yeah, that's the easiest way. In other words, we could use the law of sines in the same way we just used it to come up with angle C. But that's the harder way. Go ahead and do that on your calculator. Add those two and subtract from 180. What do you get for angle C?
106.3.
Now let's do the smell test. Is the longest side opposite the biggest angle?
Yep.
And is the smallest side opposite the smallest angle?
Yep.
Okay, then as long as that, and the medium side is opposite the medium angle, 45 degrees. And
Cool.
so once you prove that, that's a pretty good indication that you haven't messed up the math anywhere. Because usually if you make a mistake in the math, you get answers that don't make any sense. You know, they don't pass the smell test or the ballpark test, whatever you want to call it. All right. Now, have you gotten to the ambiguous case of the law of sines yet?
I think we might have done that.
Well, I'm not really going to have enough time to explain it or talk about it in detail. I can say this, it's the only difficult part of the law of sines or the law of cosines. Everything we did tonight was very basic, easy, one variable only, you just have to solve for it. And you have to know the general formula. And you have to know where it applies. And you have to know the law of sines. But none of that's difficult. The one thing that is difficult is when you have a situation where they give you 3 pieces of information and they give you a triangle like this. Okay. Notice 3 pieces of information. They usually always give you 3 pieces of information and then ask you to solve the whole thing. Well, like I said, I'm not going to have time to show you how to do it, but at least we can talk about it. There are actually 2 triangles that fit this description. One of them is that one right there. The other one is that one right there. Notice that in both cases, this is 8. In other words, they are both an 8, 10, 45 degree angle triangle. And yet there's 2 different solutions. One of them is the big blue triangle, and one of them is the triangle that has the red side as one of its edges.
Okay.
Okay? And the way you determine it, well, we got enough time to go through it. Let's go through it real quick. Is you try to use the law of sines to solve it. Okay? So I'm going to do it just because I'm more comfortable probably using it than you. So the sine of 45 over 8, remember you can go either way as long as you're consistent, equals the sine of angle C over 10. When I go to solve for sine of C, I get sine of C equals can you give me that number?
Yeah.
Or figure out that number and then take the inverse sine of it.
Okay, it's 0.88375.
I'll take the inverse sine of that.
62.1.
62.1 degrees. That's that angle right there. Okay?
Okay.
So that's one solution. If there is a second triangle, it will be, that angle will be the supplementary angle. Well, what's the supplementary angle to 62.1? 117. Whoa, hold it. I'll let you do it on your calculator.
Okay. Yeah, 117.9.
Now, always figure out this angle. Because if that angle fits in this original triangle, of which I only know one angle, then it's a legitimate solution. And in fact, it does fit, because 117 and 45 do not exceed 180. So that angle would be 117.9. Together they'd be 162.9, which makes this 17.1. So there's your your two separate triangles that came about from this condition right here, where you have an angle and side-side angle, basically. But you do have a side opposite the angle. So when you go to use law of sines, always check what this supplementary angle is. And if there's room in the triangle for it, it's a solution. Let's say that supplementary angle came out to be 140 degrees. Okay? Just going to change the conditions slightly. So this was 140. Now 140 and 45 don't fit in a triangle. So I would say that's not a solution. Only go with the first number. If it fits, it ships. Now, if it fits, then it is a second triangle. If it doesn't fit, then it's not. And the reason it's called the ambiguous case of the law of sines is because you never know until you go to solve it whether you're going to have one unique triangle as a solution or two of them.
Okay.
And it's this part right here that's the easiest way to figure it out. There are dozens of methods on how to tell when you have an ambiguous case. I've studied a lot of them, and without a doubt, this is the easiest way right here. In other words, once you get that angle, the first one, see what the supplementary one is and see if it fits with the other known angle. And if it does, it's got its own separate triangle.
Okay, cool.
And that really is the only hard part about any of this, is that ambiguous case of the law of sines. Because it's not always going to be there. There are certain combinations where, like if this number was a 12, bigger than 10, then it's not going to work. So it's only certain triangles that have two solutions. And like I said, you don't find out about it until you go to solve it.
Okay.
All right. Jake, I'm going to let you go.
All right. Thank you.
Talk to you next Monday.
Sounds good.
Bye-bye.
Bye.